Hi students, all of you welcome. Welcome to Suneel Engineering Academy. I am Sunil Kumar Bandaru. Students, in this basic electronics through topic wise MCQ series, we have completed 7 sessions. It is the 8th one. Okay, if you want previous, click on the playlist. You can find out the previous sessions. Let us start the session. Let me check up to which we have completed. We have completed all the diodes basic questions and special diodes. After that, rectifier based questions and also transistor basics. Some of the basics completed now. These are very important questions, guys. Okay, so many students just to open and skipping the video. Due to that, you may not get anything. Okay, so by listening only, you can get. It's up to this one we have completed. Coming to the next one. A transistor has a current gain 0.99 in the common base mode. Its current gain in the common emitter mode. So current gains. Current gain in the sense output current by input current. Correct? Input current. So in case of common base, common emitter, common collector. Common base, it is denoted as alpha, it is beta, it is gamma. Okay, so alpha is very much less than beta and beta is also less than gamma. So here alpha they have given 0.99 and beta they are asking. We know beta is very higher. So if you want to get high means alpha by 1 minus alpha. Whenever the denominator is low, beta is higher. Okay. So like that you can remember the formula. Alpha is 0.99 by 1 minus 0.99. So that means 99 you will get. So the beta is 99. Okay. 99 is the answer. If they are asking common collector, current gain common collector, gamma is equal to 1 plus beta, that is 99 plus 1, 100 you will get. Okay, 100 you will get. Coming to the next question. A transistor has current gain of 0.99 in the common base mode. Its current gain in the common collector mode. Just now we have got answer alpha is 0.99 means beta is equal to 99, then gamma is equal to 100. Okay, so the answer is option A, 100. Coming to the next question. If the alpha value of a transistor changes 0.5 from its nominal value of 0.9, the percentage change in beta will be dash. The percentage change in beta will be dash. Okay. So here it is a 0.5%, guys. Okay. So the change in beta. Dou beta by beta is equal to dou alpha by alpha by 1 minus alpha. Okay, so we know beta is equal to alpha by 1 minus alpha na. Dou beta by beta is equal to dou alpha by 1 minus alpha. So that is the change in alpha they have given 0.5 percentage by 1 minus alpha means 1 minus 0.9, that is 0.1 you will get. So you will get 5% change. Okay, a small change in alpha is large change in the beta. Okay, so we can also calculate this one. For example, if the alpha is equal to 0.98, you will get beta is equal to 49. If the alpha changes to 0.99, if you want, you can calculate it. Beta is equal to 99. So small change, just 0.01 change in alpha, the change in beta is nearly 50. Okay, large change in the beta. Here 0.5% means here nearly 5%. Okay, coming to the next question. The bipolar junction transistor, if alpha is 0.98, IB is equal to 100 microamps, IC naught is equal to 6 microamps, then what is the IC and IE? What is the IC and IE? All of you listen carefully, guys. Now I want to give a very good trick. Okay, All of you ready for the trick? Yes. Very good, guys. So here a small idea for the transistor is a common idea, guys. It is the emitter, it is the base, it is the conductor, correct? So if you are giving IE as the input current, then some of the current will be flow through the base and remaining will goes to the collector, correct? That means we know very well in our electrical, output is equal to input plus losses, like that. So from this one, what we can say that IE input is equal to output plus losses. IE is equal to always IC plus IB. IE is equal to always IC plus IB. That means from this one, what we can get understand, IE is little greater than the IC. IE is little greater than the IC. I think some of the students still not getting. No idea for it. If you are sending 100% as IE, then IC may be 98 or 99. Then IB remaining 1 or 2. Okay, this is true for any type of transistor. If you are sending IE as 100 amps, then IC is 98 or 99, IB is 1 or 2%. So from this one also, what we can understand, input is always higher than the output, correct? Always higher than the output. So here they are asking IC and IE. IE is always higher. So second one higher. So IC is less than IE. So let us check which option is correct. First one satisfies, second one not, third one not, fourth one not. Okay, so first one only satisfies, so directly you can use the answer. In the examination, we no need to write all this now. Just I am saying that here in the three currents, IE is equal to IC plus IB. If you send IE as 100, IB is just 1 or 2%, then IC is 98 or 99%. So IC is somewhat of less than the IE. So if you check that one, first option is correct. So directly we can use the answer. Directly we can use the answer. Getting? This is a very important thing. From this one, you can get a lot. You can get a lot. For example, if the base, this is also considered as base is common, na? So common base. In common base, what is the current again? Alpha. Alpha is equal to output by input. IC by IE, na? So IC is nothing but 98 if you can consider. IE is 100%, then 0.98. So that means less than 1. Less than 1. So in common base, current gain is less than 1 or very nearly equal to 1. So lowest current gain. Lowest current gain. All of you clear? Very important. Common base, lowest current gain. Okay. So if you know this concept, you can easily get the answers. So if you don't want this one, if you want conventional method, you can also go with IC is equal to beta into IB plus 1 plus beta into IC naught. Substitute the values. If the alpha is 0.98, what is the beta? You can calculate. You will get 49, guys. 49 into IB is 100 plus 1 plus beta, 49 plus 1, 50. IC naught, they have given 6 microamps. So 4900 microamps plus 300. So that means total 5200. So IC is 5200 and IE is equal to what I have given, IC plus IB. So 5200 plus IB they have given 100, 5300. Okay. So but no need to do all this. Just to go with the logic, then you can easily get the answer. Here why I am giving this much of explanation, because so many students are getting worried about this electronics. They are feeling it is very difficult. So it is not difficult. It is very easy. You have to do only one thing. You have to attend for the classes. Okay. So you have to watch all the classes and note down the important points and practice the questions. Okay, so then you will get nearly 80 to 90% in this basic electronics also. Okay, coming to the next question. In bipolar junction transistor, which configuration is also called as emitter follower? Which configuration is also called as emitter follower? That is common collector. Common collector is also called as emitter follower. So here collector is common. Okay, base may not be used as the output. So that's why we have to use as input, and here IE. So here IE is almost equal to IC. Okay, so almost equal to IC. So both are very nearly equal. So that's why here this common collector is called as emitter follower. Emitter follower. And in case of common collector, the very important thing is output side emitter is there. Now emitter is there means heavily doped. Heavily doped means resistance is less, low resistance. Base input resistance is high. Input resistance is high. Okay, here output resistance is low. Output resistance is low. So as output resistance is low, input resistance is high, then what about the voltage gain? Voltage gain. So our output voltage by input voltage. Output low resistance means low voltage drop. Low voltage drop. So output is low. Low. Input is high voltage means high voltage drop. So input is high. Low by high means lowest. So voltage gain is lowest. Voltage gain is lowest. And common collector, what about the gamma? Gamma is equal to 1 plus beta, highest. So highest current gain. Highest current gain. So common collector, highest current gain, lowest voltage gain. Okay, so that is some another important point. Emitter follower, common collector, and it is mainly used for impedance matching. Why? Because the output resistance is low, so we can easily match with the impedance of the load. Impedance matching. That is the advantage of this common collector. Okay, these two are very important, guys. Impedance matching, emitter follower. Yes, here they have given which configuration is also called as impedance matching common collector. Okay, which has highest voltage gain. So these type of questions I have already given the explanation, but still so many students are in the confusion. Don't worry, I want to give a small explanation about all these three configuration. So all of you try to note down and how to be concentrate. Okay, so if you are not concentrate, it is very difficult to remember. Okay, so by heading is not at all the matter. So many electronic students also don't know this much of simple subject. Okay, so common base, common emitter, common collector. Okay, so base is the common, guys. So base is the common. Remember one thing, or note down the point. Base is nothing but, for example, if you send IE as 100%, then base is 1 or 2%, IC is 98%. Let us consider. Okay, so if you connect this one as output, this one as output, that is not serves our purpose. Okay, so base may not be used as the output. Okay, we may not use as the output, and the same way collector may not be used as the input. Those 2 points. Base may not used as output, collector may not be used as the input. Okay, in general purpose. Okay, so here base is common, input is emitter, output is collector. Okay, so here common emitter is the common. Base may not be used as output now, so base may make it as input, IC. Common collector is common, and here emitter, and here input is base. Now first of all, coming to current gains. Current gain, so many times we have discussed, here current gain is alpha. Alpha is equal to IC by IE, correct? Beta, IC by IB. Gamma, IE by IB. Okay, let us take IB as 1, then IC as 99. Okay, so let us take these examples. If alpha is equal to IC as 99, IE as 100%, so that means it is very nearly equal to 1. So lowest current gain. Lowest current gain. Very important question. Which is lowest current gain? Common base. Got it? Is there any difficulty here to remember this? A very simple. It is lowest current gain. So and also very nearly equal to 1. So that means alpha is nearly equal to 1 means, if it is nearly equal to 1 means output is equal to input now. Output follows the input. Output follows input. Correct. Whenever the output follows input, it is called as buffer. So it is called as current buffer. Very important question, guys. The following which configuration act as current buffer? Okay, that is common base. Okay, all of you clear up to this? Now coming to the beta. IC by IB. IC is 99. IB is 199. So high. Current gain is high. Here gamma I is 100, IB is 100%. So highest. So very important question. Which is highest current gain? Highest current gain. That is common collector. Common collector. Okay. So all of you pause the video and note down all the important points, and after the class revise 1 or 2 times. Okay. Now coming to the next important points. Just wait. Very easy, guys. Common base, common emitter, common collector. So current gains completed na. Voltage gains. Voltage gains are depend upon resistance. So we have to get idea about resistance. What about the input resistance? What about the output resistance? So there is no specific explanation for this, but we can understand by our own. How we can understand by our own? Here input side emitter is there. Emitter is the heavily doped. Whenever the doping is higher, it will looks like a conductor. Okay, so that means low resistance. Heavily doped means low resistance. So resistance is low. Input side emitter is there, so low resistance. Okay, input is low means with comparison of input, output is high only. In the same way, common collector. So in common collector, just opposite, guys. Common base and common collector is opposite. Why? Because here emitter is input, here emitter is output. So emitter is at output side means high, the heavily doped, that means low resistance. Resistance is low. And input side base is there. Base is lightly doped, so high resistance you will get. In common emitter, both are medium, guys. Comparing of these two, these are both medium. Okay, these are also important for exams. Now voltage gain. So output voltage by input voltage generally. Output side high resistance, high voltage drop. So high by input side low resistance, low. High by low is nothing but highest. Very important question. Voltage gain is highest in case of common base. Here medium means high. Here low by high, that is lowest. Or voltage gain is very nearly equal to what? Very nearly equal to means you can say it is a voltage buffer. Very important question. So current buffer, common base. Voltage buffer, common collector. Okay, getting? Common collector. And here voltage gain is high, current gain is also, both are high. So power gain is highest. Okay, and common collector is also called as emitter follower emitter follower. Okay, those are the important points. This is as per the concept. We don't want this much of concept also. We want very short tricks. So whenever we see the question, we have to do the answer without anything. We have to save the time. Anybody asking like that? Anybody want like that? Yes. For those persons, I am giving some more tricks. Okay. Some more tricks. Ready? Very interesting topic. Very interesting. Very interesting. And if you like these classes, you have to share, guys. Share your experience, how the classes are running. Okay. Through the comments or likes. And you can also send to your friends. Okay. Simple, guys. These are very silly tricks. Nowhere you see this one. Common collector. So C is dominated. C into C square. C is dominated here. C for current. So C's are higher here. So currents are higher. So current gain is highest. Current gain highest. All of you clear? Current gain is highest in case of common collector. So in 3 configurations, C's are higher here, current gain is highest. Okay, whenever the current gain is highest, opposite term, voltage is the opposite term here, voltage gain is lowest. Voltage gain is lowest. Lowest in the sense, very nearly equal to 1. Nearly equal to 1 means buffer, voltage buffer. We got all the points. Very easy. And one more thing. So common collector, common base, both are opposite, I said. Opposite, I said. So here current gain highest means here current gain lowest. Current gain lowest. Voltage gain lowest means very nearly equal to 1. So current buffer. Current buffer. If you don't want to remember this one also, we can simply make CB. C for current, B for buffer. Okay. C for current, B for buffer, current to buffer, current to buffer. Buffer in the sense output is almost equal to input. That means very nearly equal to 1. That is lowest. Okay. So this is like a circle manner. Wherever you have started, that will be ends are the same. Okay. Current buffer. So current gain is lowest means voltage gain highest. Voltage gain highest. Okay. So in case of common emitter, both are high, voltage gain high, current gain high. So both are high in the sense power gain is highest. Power gain highest. So that's why in most of the amplifier we are using this type of amplifier, all the audio devices. Okay. In high frequencies we can go with the common base. In impedance matching, that is last stages, we use the common collector. Okay, so I think all of you got a very important tricks. Then whenever we see the questions, you can directly give the answer with the concept or with the tricks. Okay, students, here you have the provision. You can watch 2 times or 3 times also. Okay, just to pause the video, note down, and if you want, you can listen again. Okay, here which configuration gives highest voltage gain? Highest voltage gain. Common collector, current gain highest. Then opposite common base. Common base is the highest voltage gain. Okay, simply we can get. CB is a current buffer. Current buffer means voltage gain highest. Like that also. Which configuration having highest power gain? Highest power gain, common emitter. So common emitter. Voltage gain nearly equal to what? That is voltage buffer. Voltage buffer or voltage is low. Current highest, voltage is low. That is common collector. So common collector in the sense, answer is option D. Okay. Which is current buffer? Current buffer. C for C, current. B for buffer, CB, common base. In common base, alpha current gain. That is very nearly equal to 1. So current buffer. Okay. Like that, you can simply give the answer. Bipolar junction transistor C configuration, the phase shift between input and output. In only common emitter configuration, we have the phase shift 180 degrees. Remaining two, no phase shift. CB and CC, no phase shift. No phase shift. Okay, only common emitter configuration having phase shift. Okay, and this stability based questions are biasing based questions and power amplifiers. We will discuss those in the next session, guys. Okay, and one more thing, guys, you have to follow each and every session, guys. Okay, then only you will get a very good knowledge in this basic electronics. Here I'm giving concept and also remembering tricks and all those. Okay, so nowhere you will get this type, this grand show. Okay, so why? Because I have not used any of other person's tricks. These are my own tricks. Okay, only for our students. Okay, yes, and please give your comments and also likes. Okay, then only I can get some motivation to make more videos. Thank you, students.